Somewhere in the silent darkness of space, there are places where the universe seems to break its own rules. Astronomers first noticed something strange while observing distant stars. In certain regions of the sky, stars were moving in unusual ways, swinging around empty space as if something massive was pulling on them. But when scientists pointed their telescopes at these locations, they saw nothing. No glowing star, no visible planet, just darkness. Yet the invisible object had an enormous gravitational pull, strong enough to control entire star systems. It was as if space itself was hiding something. For decades, this mystery puzzled scientists. What kind of object could be so powerful, yet completely invisible? Eventually, a shocking possibility emerged. Somewhere out there in the deep vacuum between galaxies and stars, there might exist regions where gravity becomes so extreme that even light cannot escape. Imagine that for a moment. Light is the fastest thing in the universe. It can travel nearly 300,000 kilometers every second. It escapes from stars, races across galaxies, and carries the images we see through our telescopes. But in these mysterious places, even light disappears. Astronomers gave these strange objects a name: black holes. A black hole is not just a dark object floating in space. It is a region where gravity becomes so powerful that it traps everything nearby: dust, gas, planets, stars, and possibly even time itself. Around each black hole lies an invisible boundary called the event horizon. This is often described as the point of no return. Once anything crosses that boundary, escape becomes impossible. No signal can come back. No message can reach the outside universe. It is as if reality itself suddenly ends. Yet black holes are not rare cosmic accidents. Scientists now believe there may be millions or even billions scattered throughout the universe. Some are small, formed when massive stars collapse at the end of their lives. Others are true giants, supermassive black holes hiding in the centers of galaxies, including our own Milky Way. But this raises a question that feels both terrifying and fascinating. What would actually happen if someone drifted too close to one? What would you see as you approached the edge of the event horizon? Would you be destroyed instantly? Or would you witness something far stranger hidden in the deepest regions of space? To answer that question, scientists first had to solve an even bigger mystery. How did we discover something that cannot be seen at all? The universe rarely reveals its secrets directly. Sometimes the only way to discover the invisible is by watching how everything else behaves around it. In the early 20th century, scientists were trying to understand one of the deepest mysteries in physics: gravity. For centuries, gravity had been explained as a simple force pulling objects together. But in 1915, a brilliant physicist named Albert Einstein proposed something far more extraordinary. In his revolutionary work known as the General Theory of Relativity, Einstein suggested that gravity was not just a force. Instead, massive objects actually bend the fabric of space and time itself. Imagine placing a heavy ball on a stretched sheet. The surface curves around it, and anything nearby begins to roll toward the center. According to Einstein, stars and planets do something very similar. but on the scale of the universe. Most objects create only small curves in space, but Einstein's equations hinted at something far more extreme. If a star were massive enough, and if it collapsed under its own gravity, space could bend so deeply that it would form a kind of cosmic pit, an invisible region where escape becomes impossible. At the time, even Einstein himself was unsure if such objects could truly exist. For years, the idea remained mostly theoretical, a strange mathematical prediction hidden within complex equations. But the universe had already begun leaving clues. Decades later, astronomers started observing stars behaving in very unusual ways. In certain regions of space, stars were orbiting something massive, yet telescopes could see nothing there. No shining star, no glowing gas cloud, just darkness. One famous example appeared near the center of our own galaxy, the Milky Way. Astronomers tracked the paths of several fast-moving stars that seemed to be circling an invisible object with incredible speed. The gravity required to control those stars was enormous, millions of times the mass of our Sun. Yet the object itself remained completely hidden. It was as if a gigantic cosmic predator was sitting quietly in the darkness, revealing its presence only through the motion of the stars trapped around it. Slowly, scientists began to realize something astonishing. These strange observations might be the first real evidence that black holes were not just theoretical ideas, but actual objects scattered throughout the universe. But if black holes truly existed, another question immediately followed. If something fell toward one of these invisible giants, what would the journey actually look like? And what would happen at the very edge of the point of no return? Imagine drifting silently through space toward a place where the laws of the universe begin to twist. From far away, nothing seems unusual. There is no giant shadow, no obvious warning sign floating in the darkness. A black hole does not look like the spinning monsters often shown in science fiction. Instead, it hides quietly in the depths of space, invisible against the black background of the universe. But as you move closer, something strange begins to appear. Around many black holes, clouds of gas and dust form a brilliant ring of light. This glowing structure, known as an accretion disk, is made of matter falling inward at incredible speeds. Friction heats the material to millions of degrees, causing it to shine brighter than entire stars. To a distant observer, it might look like a fiery whirlpool spinning in space. Yet the real mystery lies closer to the center, where the light suddenly vanishes. At that boundary exists something scientists call the event horizon. It is not a solid surface, and it cannot be seen directly. Instead, it is an invisible border surrounding the black hole. Cross it, and escape becomes impossible. Not because something blocks your path, but because gravity bends space so severely that every possible direction leads deeper inward. Even light, the fastest thing in the universe, cannot climb back out. Now imagine slowly approaching that boundary yourself. At first, you might feel nothing unusual, but gravity near a black hole changes rapidly with distance. The pull on your feet would become much stronger than the pull on your head. Gradually, the difference in gravity would begin stretching your body. Scientists call this strange process spaghettification, because objects are pulled longer and thinner as they fall deeper into the black hole's gravity. But something even more mysterious happens at the same time. To someone watching from far away, your fall would appear to slow down. Closer and closer you move toward the event horizon, yet from their perspective, time itself seems to freeze. Your image would fade and dim as the light trying to escape struggles against the black hole's gravity. Eventually, you would appear almost motionless at the edge. But from your own perspective, nothing unusual would happen to time. You would continue falling forward, crossing the invisible boundary without even realizing the exact moment it happened. Two different realities, both correct, existing at once. And once that boundary is crossed, something even more mysterious begins. Because beyond the event horizon lies a region of space that no scientist has ever observed, and where the known laws of physics may no longer apply. So what truly waits in that hidden darkness at the center of a black hole? Deep inside a black hole lies one of the greatest mysteries in all of science. For decades, physicists have tried to understand what truly happens beyond the event horizon. But the truth is unsettling. Once something crosses that boundary, the universe gives us no direct way to observe what follows. It is like a door that closes forever. Yet the laws of physics still try to describe what might be waiting inside. According to the equations of the general theory of relativity, everything falling into a black hole should eventually be pulled toward a single point at its center. This point is known as a singularity, a place where gravity becomes infinitely strong, where space and time themselves collapse into something unimaginably small. In theory, the singularity is where all the matter that enters the black hole is compressed into an extremely dense point. Planets, stars, gas clouds, even light could be squeezed into this tiny region. But here is where the mystery deepens. When scientists try to apply the known laws of physics to a singularity, the equations begin to fail. They produce impossible results. It is as if our understanding of the universe simply stops working there. This suggests something extraordinary. Black holes may be hiding physics that humanity has not yet discovered. Because of this, some researchers have proposed strange and fascinating possibilities. One idea suggests that black holes might not destroy everything they consume. Instead, they could act as gateways connecting distant regions of space. In theory, such tunnels through space-time are called wormholes, shortcuts that might link two separate points in the universe. Another possibility is even more puzzling. For years, scientists believed that anything falling into a black hole would disappear forever. But modern research has raised a disturbing question. Can information truly be destroyed? In physics, information about an object, its structure, energy, and history should never simply vanish. If black holes erase that information completely, it would break a fundamental rule of the universe. This puzzle has become known as the black hole information paradox, a mystery that continues to challenge some of the brightest minds in science. So what really happens inside? Do black holes crush everything into a singular point? Do they hide tunnels across the universe? Or do they store the history of everything they consume in ways we still cannot understand? Somewhere within that invisible boundary, the universe may be hiding answers that could transform our understanding of reality itself. And recently, scientists came closer than ever before to actually seeing the shadow of one of these cosmic giants. For most of human history, black holes existed only in equations and theories. They were predictions hidden inside complex mathematics, objects so strange that many scientists once wondered if they could truly exist in the real universe. Then, in 2019, something extraordinary happened. A global network of telescopes working together across Earth achieved what once seemed impossible. This project, known as the Event Horizon Telescope, captured the first ever image of a black hole. The target was a gigantic black hole located in the center of a distant galaxy called Messier 87. When the image was revealed to the world, it looked both simple and mysterious, a glowing ring of light surrounding a dark circular shadow. That shadow was not the black hole itself. It was the silhouette created by the event horizon, the region where gravity becomes so powerful that light cannot escape. For the first time in history, humanity was looking directly at the edge of one of the universe's most powerful objects. But the image did more than confirm that black holes exist. It opened a new chapter of exploration. Because while the glowing ring revealed how matter behaves near a black hole, the dark center still hides the greatest mystery of all. What happens beyond that shadow remains completely unknown. Scientists continue studying these cosmic giants using powerful telescopes and computer simulations. They observe stars racing around invisible centers of galaxies. They detect bursts of radiation from matter falling into extreme gravity. Every observation adds another small piece to the puzzle. Yet the deeper we look, the stranger the universe appears. Black holes challenge the very foundations of physics. They bend space, they slow time, they trap light itself. Some researchers believe understanding black holes could unlock a deeper theory of the universe, one that finally connects gravity with the strange world of quantum physics. If that happens, black holes may reveal secrets about the birth of the universe, the nature of reality, and perhaps even the ultimate fate of everything that exists. But for now, their deepest secrets remain hidden behind the event horizon, a silent boundary where information cannot escape, a place where our current knowledge reaches its limit. And somewhere in that darkness, beyond the shadow we have finally seen, the universe may still be hiding answers that humanity has not yet learned how to ask. The universe is far bigger and far stranger than we once imagined. Every discovery brings us closer to understanding these cosmic mysteries, but many questions still remain unanswered. If you're curious about the secrets hidden in the depths of space, the story is only just beginning. Subscribe to the channel and join us as we continue exploring black holes, distant galaxies, and the most fascinating mysteries of the universe. Because out there, in the silent darkness of space, the next great discovery may already be waiting.